Hey, Dr. Holtzman, this is Robert Clark here, and we're going to talk about FTL, faster than light travel. Okay, before we go anywhere, I want to talk about the scientific spectrum of progression. So we have conjecture. That's the place where we start. We know what we want to do, but we don't even know if it's possible. Okay, so brainstorming, right? Then we have speculation. We know what we know, and we know what we don't know. Okay, so we brainstormed. We said, okay, these are the laws of physics that we know. These are the things that we don't know. Let's work from there. Science. You know how nature works, and you can now start running experiments to test your hypothesis. All right? Then from science, we go to technology, where we can apply our knowledge of science to the real world and start solving problems with it. And then we get to application, the ultimate progression in the science technology spectrum, when the technology is good enough that it's ready for everyday use. That's the exciting thing. That's where we all want to be with our science.
Alright, so this is the graphic that I found to describe the progression from conjecture to application. It's taken from the NASA website, and I thought it was really interesting and useful for this discussion.
We're all familiar with science fiction types of faster light travel. I mean, we have the warp drive from Star Trek, we have Mass Effect's Mass Effect drive, which lowers the mass of everything inside of a field. And then Star Wars' hyperdrive, which introduces a dimensional shift, which allows the ship to travel faster than light, and so on and so forth. Also, Event Horizon uses wormhole teleporting. So those are the science fiction types. But what I'm concerned with is the scientific types that we're actually working on presently.
Scientifically speaking, you need two things when you're going to travel faster than light. You need, one, a drive that can propel you through space faster than light, and two, you need a propulsion system.
So you need a standard propulsion system in your ship that is going to go faster than light. But what is the drive going to be that's going to make you go faster than light? Well, wormhole teleporting, big issue. You have to already be where you're going to be. So we have to get there somehow first. Then maybe it'll be cheaper to teleport. We don't know yet. Affecting the mass of an object so that it's weightless and can travel at light speed or faster. Can only do that with a substance we haven't discovered yet that has that property under certain conditions. We haven't found it yet. Or with an infinite amount of energy, which coincidentally is the same problem with achieving light speed with matter right now, is it takes infinite energy. So affecting the mass of an object to make it go light speed or faster, not going to happen. Dimensional shifting, once again, we have no idea how to do that. We are in the point of conjecture there. So, the last one, the warp drive from Star Trek. Alright, really cool stuff. This came out of the mind of a Trekkie. His name is Astronomy. He is a physicist. He wrote a paper, a mathematical proof, that expresses within the laws of general and special relativity the ability to travel faster than light. Now, the big problem is massive objects, anything with mass, can't achieve the speed of light. They just can't. So we have that barrier, and the object that we're trying to accelerate is made of the same stuff as that barrier. So we need to figure out what to do to get past it. Here's where the cool stuff comes in. Space-time has no mass. Einstein proved or used mathematics to demonstrate it, and we have since pretty much confirmed it. We've found no evidence to the contrary and a lot of evidence to support it. So really cool stuff there. It doesn't have mass. There's no speed limit to how fast we can make it go. We just have to figure out how to make it go. So Astronomy proposed a drive system that will scrunch space in front of a ship and expand it behind it. And so as it scrunches, it kind of wraps around the front of your ship and then expands behind, leaving you with a small pocket of space, time, that isn't changing.
This graphic describes the different shapes of warp bubbles that we'll be talking about throughout the video.
You're traveling at whatever your speed is inside of that, not violating your local speed of light. However, because you're shrinking space in front of you and pulling it around the ship and expanding it behind, space-time is pushing you forward in relationship to Earth, in relationship to observers off of your ship. That's how you achieve faster than light travel. You make space do the work, because space can do that work. Okay, now you say, well, that seems ridiculous, we can't do that. Well, Harold Sonny White, a physicist with NASA, is presently doing some experiments in the Apollo labs in Florida, the rooms that are seismically isolated so that earth tremors won't throw off his results, to see if he can redshift a laser inside of a vacuum passing through an electromagnetic ring, trying to see if he can create a warp field in there. Because if it is redshifting in comparison to another laser right here, not passing through it, he knows he's created a warp field inside that ring. And we can then take that and start making it into technology. So we're no longer in the realm of conjecture or speculation with faster than light travel. We are in the realm of science. We may be going to stars like Alpha Centauri or Betelgeuse and observing them firsthand. How cool will that be for us to be able to go and see these things that we see through our telescopes all the time, first person? Astronomers are always complaining how we never get to do that. Well, we may be having the opportunity within my life.
First, Dr. White needs to prove that he can create the warp bubble by redshifting his laser. Then we can scale it up to a ship with a propulsion system, and which will be responsible for automating the flight to and from the probe's destination and bringing it back safely. In order to achieve this, we will need to make the warp field that multiplies our relative speed by 10 times the speed of light, so that we can arrive at our destination arbitrarily fast without ever violating the local speed of light. To do this, we'll need to make the warp field look something like this instead of something like this. This takes the same amount of energy as is contained in the mass of the planet Jupiter, so 300 times Earth. This one contains the energy of a mass somewhere around twice the size of the Voyager probe, or 3,200 pounds. If we then oscillate this according to Dr. White's mathematics, we can then reduce the energy requirements down to something about the size of the Voyager probe, so 1,600 pounds. This will allow us to get where we want to go in about 1/10 of the time it would take light to travel to us from there, without ever violating the local speed of light. So that's where we are with warp drives and FTL. Thanks for listening. Have a good day.